Hello and namaste. In continuation of the partial differentiation, we are dealing here with the composite function part 2. So change in independent variable x and y by other two variables u and v. So let us suppose z is a function of x comma y and x is a function of u and v. Similarly, y is also a function of u and v. Then if you wanted to draw this tree diagram, it will happen z equals to f, which is depending upon x and y, but x and y, they are independently depending upon u and v. So x is depending upon u and v, y is also depending upon u and v, wherein this z equals to f, level 1 variable, x and y, they are the variables in level 2, and u and v are the variables in level 3. So whatever we have seen in the part 1, this type of tree diagram will differ from that one. If you'll observe here, this is z equals to f, which is depending upon x and y, and this x and y depending upon t. That was the first part has been given, or which we have discussed on. What is the difference? You can easily check it out here. So if we wanted to differentiate this z with respect to u, which is the variable in the level 3, but here this in the level 3 we have got two variables u and v. These are the two different variables we have got. So if we wanted to differentiate z with respect to u, that would be partial differentiation, dou z upon dou u. Now, as I have told you before also in the part 1, that this u and v, they are not, we cannot directly differentiate this z with respect to u and v. We have to take the help of this intermediate variables x and y, and that's the reason the chain rule will exist. And therefore it's equals to dou f upon dou x. Again it's dou upon dou, because the partial differentiation, because in the level 2 also we have got two variables. That means from this z, two arrows are coming out, x, two arrows are coming out, y is also two arrows are coming out. From each and every variable we have got two arrows are coming out. So each and every differentiation, whatever we are doing with the previous level to the next level, everything would be a partial. So dou f upon dou x into dou x upon dou u, plus dou f upon dou y into dou y upon dou u. Similarly, dou z upon dou v will also given on the same way, and this is nothing but is the difference between this part 1 and part 2, and the dealing or the approach of this type of examples would be little different than what is we have seen in the part 1. So that's the reason I've divided into two different parts. If z equals to f of x comma y, where x is e to the power u cos of v, y is equals to e to the power u sin v, then show that y into dou z upon dou u plus x into dou z upon dou v is equals to e to the power 2u dou z upon dou y. Let me just deal with this first. So now here we have got x is equals to this, y is equals to given by this function, and if you'll observe, this type of diagram will come into the picture. Now if you'll observe here, we have got almost same, all the variables are same, so z equals to f, x, y and u and v. Okay, so we can just go with this type of, otherwise we have to make some changes in the particular variables, like instead of z, if we have been given here u, we have to write down here u, but we do not have it. We have the same variables over here. Then as I have told you, because every time from every variable two arrows are coming out, that means what, we have to have everything in partial differentiation. So dou z upon dou u is dou z upon dou x, dou x upon dou u, dou z upon plus dou z upon dou y into dou y upon dou u. Just we have to take this differentiation. So now dou z upon dou x, this function will remain as it is, because it's been defined as just f of x comma y. We have not known what function is this. What function is it? This is just a function of x comma y. Now few of the books are saying this as dou z upon dou x, or few of them might be writing it as f dash of. So it's also one of the this dou z upon dou x into e to the power u cos of v plus dou z upon dou y e to the power u sin of v. Then this is nothing but x dou z upon dou x plus y dou z upon dou y. Then similarly, because this is dou z upon dou x, we want dou z upon dou u, we want y with that. That's the reason we have multiplied this particular equation with y, both the sides, so we have got this sides. Then similarly, dou z upon dou v, we have found out with the same way, I'll just go quickly because it's just a partial differentiation. And then we have to just multiply this dou z upon dou v with x. That means multiplying this entire equation with x, and we are going to get this. And if you add them up, so we are just adding, suppose this is first equation, this is the second equation, adding them up, we'll be getting this type of thing, which we are going to get it like this. So this is nothing but this is x squared plus y squared, which is x, the value of x and value of y, we are putting it from this equation. Just simplifying, so cos squared e to the power 2u is out, cos square v plus sin square v will gives us, so this will reduce to the 1, and we will get here or remain here with the answer which we wanted to prove that. It's a very simple type of example, provided you should understand this diagram, as well as whenever we are writing out the partial differences, so the chain rule, if you have done with that, then this type of examples are truly simple. Now let us prove this second part, which has been given to us as, so it's dou z upon dou x the whole square, and it is dou z upon dou u the whole square. So we have to deal here with this, because see, we have got x is e to the power u cos of v, that is dou x upon dou u, we have to find out, dou x upon dou v we have to find out. Similarly, y is this, so dou y upon dou u and dou y upon dou v. So this 1, 2, 3 and 4 variables, we will need it in this type of way, that is dou z upon dou u. So we are starting with this, so we are trying to achieve this and this, adding them up we will get that. So it is nothing but dou z upon dou u is equals to dou z upon dou x, whatever the chain rule we have seen in the last case. Same way here we have to do dou x upon dou u, the value we have taken it from here, because x and y they have defined it separately here. If you'll observe here, this is x and this is y, so accordingly we will have to differentiate that y with respect to u and v, x with respect to u and v. Same way what we have done, so we have just put the values over here, these variables, and we will be getting e to the power u. Why e to the power u? So e to the power u from here, e to the power u from here, so we have taken it out, e to the power minus u to the other side, and we got this as. And then why are we doing that? Because we have to have this type of thing, so we need to have a squaring of both the sides. If we square both the sides, we are going to get, because it's like a plus b the whole square, so we have to deal with that. So again this will gives us here is, so this is suppose equation number 1. Then equation number 2 we are going to achieve, so we have started with dou z upon dou u, now dou z upon dou v, the same way what we have done it here, same way again squaring of both the sides, will be getting this as a second equation. What we have to do it, we have to just add them up, so LHS will get added, RHS and RHS will get added, and if you observe here, dou z upon dou x the whole square, dou z upon dou x the whole square, and we have got cos square v, sin square v. So if you observe here, we have got this will move to 1, this will also move to 1, and we will remain here with the answer. So this is e to the power minus 2u dou z upon dou u the whole square plus dou z upon dou v the whole square is equals to dou z upon dou x the whole square plus dou z upon dou y the whole square. So this is what is the approach for the next type of example. Though it is looking like little difficult or more number of dou and the x and y and z and u and v, but if we'll just try to solve it like this, the way which we have done it in this way here, you will understand it. So always try to draw this type of diagram whichever is the question given to us, then it will be easy for you to go about it. Okay, and this is a self-observation slide wherein 2 questions has been given to you, and it is a proof that question, so it is easy for you all to go about and find out this. Thank you so much. Happy learning.